Hello everyone and welcome to yet another recreation programming session with Mr. Zozen. Some time ago we developed a very interesting library which is called Olivc or Olivets depending on how you want to pronounce it. And it's a very cool small library which is basically very cross-platform because it doesn't use any specific API. It's an API of itself. Right, so essentially it's just a bunch of algorithms that allow you to draw different primitives into a given array of pixels. Right, you just give it an array of pixels and then it will just draw things into that. And because of that, it's insanely cross-platform. Obviously, it's kind of slow, right? It doesn't use any hardware acceleration or anything like that, but it's extremely cross-platform because you can have an array of pixels anywhere, right? So, and it doesn't even use, in some cases, standard libraries. So because of that, you can even compile it to WebAssembly, right? So, and we have a bunch of demos in here, right? So, which demonstrate how the library works. As you can see, you have gradients, you have transparency, right? So you can do a little bit of a 3D in here. So you can stretch textures and stuff like that. You can even have like a Z buffers. As you can see, the polygons are intersecting, and that is done through Z buffering and stuff like that. Again, we're not using any hardware acceleration or anything like that. The library literally just implements the rendering algorithms that work pixel by pixel, right? And this is how it's done. So you can rotate textures, you can have textures in 3D, and you can also have 3D models and stuff like that. So it's actually kind of cool. It's actually kind of cool. I'm gonna keep the link to this entire thing in the description if you are interested. I would like to actually add another demo in here, another 3D model, right? So on our Discord, by the way, right, so there is a pretty funny meme going on. So people draw these sort of pictures of this creature. And the members of our community actually collecting drawings of this penguin, which is called Panger, right? So I don't really know what's up with that or what it represents. People just on our Discord do that. And somebody created like a 3D model of this creature, right? I'm gonna keep the link of that is dedicated to this creature in the description as well if you're interested, right? So somebody created 3D model and it's an OBJ file, and our demo system actually supports OBJ files. In fact, all of these models are OBJ files. They are from, yeah, there we go. We even have the emote for Panger, right? So we even have an emote for Panger. This meme is kind of getting out of control. So it's originally was just like a Discord, Discord meme, but it's kind of spilling out of the Discord, right, into the wild world. So it becomes kind of difficult to contain it already. So I don't really know what we're going to be doing about that. So anyway, right, so all of these things are OBJ files already, so that means it should be relatively easy to actually implement. So let me take a look at the entire thing. So I already copy-pasted, yeah, Panger OBJ. Here's the Panger OBJ. So here's the OBJ file. So there's some vertices in here, as you can see. Right, there's a lot of vertices. There's also some faces and stuff like that. But the cool thing about this model is that it also has textures, right? So here's the texture that is sort of like a put on top of the model, I suppose. All right, and there are additional files in here. Specifically, there is like MTL file, which I suppose is a material file, and that material file refers to the Panger PNG, which is a texture. Right, that is put on top of this entire thing. So I don't really know how exactly we're going to be rendering all of that, but I want to try to do that nonetheless. So, and the author of this model is Max Kawula. I hope I pronounced your name correctly. Right, so they created this model. So I'm going to put your profile in the description. Right, author of Panger OBJ. Right, Panger OBJ, there we go. So I always like to credit people. Max is amazing, yeah, absolutely amazing. The model itself is really cool. Unfortunately, I can't really show it, right? I wonder if I can just like open it with the Blender. Right, so obviously, here's an interesting thing. If you open MTL file, it refers to Raylib Panger blend. So I suppose it's an original file from which it was created, but OBJ is probably exported thing. I wonder if I can just open this entire thing with Blender. So let's see. Right, I do have Blender in here because I use it for editing videos and stuff like that. So I wonder if I can just do that. So Blender Queen. The format is not supported file, so argument has no blend file extension and stuff like that. So apparently you can't just open OBJ files with Blender. Blanger, yeah. So maybe you can export this somehow, but we can give it a try actually. So is there something like export? The problem with Blender is that it's extremely unintuitive because it's a piece of software that was developed in its own sort of an enclosed culture. Right, and because of that, a lot of conventions are very unconventional, right, so to speak, right? So, and I don't really know, it's kind of difficult to learn, but it's also very cool at the same time. So, yeah, okay, so there's the export in here. Okay, so I can actually export OBJ files. So there's a wavefront, there's two of them, look at that. So there is a wavefront OBJ legacy, and there's just wavefront OBJ, not legacy. Classic, isn't it? Right, classic situation. You have a legacy mode and non-legacy mode, whatever the fuck that means. Right, so whatever the fuck that means. Imported, no, we need to export. Oh, yeah, imported, I'm sorry. Yeah. So you're right. We're not exporting, we're importing this entire thing. So we go into the sorting. And can I sort? I think it's already sorted by the alphabet. Olivets. Okay. So, and this is assets, Panger OBJ. Okay, there's two files in here. I wonder if I can just open OBJ, because I'm pretty sure MTL will be referring, would be referred by Panger OBJ. Yeah, okay, so as you can see, it is referred. So I suppose I would expect Blender to actually recognize that entire thing. Here it is. Here's the motherfucker. It didn't recognize the materials and stuff, but okay, so look at this creature. So it's so fat. Oh my god, I love it. It's so cute and fat. Looks sus. Yeah, it looks a little bit sus, yeah. I really like him. So yeah, we need to put this this penguin into the demos, right? So this is Panger. Your mom's banger. Oh, the sorry. Anyways, the Panger, your mom's banger. So let me see how we're gonna be approaching this entire thing. So this project uses no build. And it uses OG no build, by the way, right? So not just like a new nob system, but it's just like actually old OG no build. Maybe I should actually migrate this entire thing to nob at some point, right? So, but right now I don't really want to do that. So first of all, the first thing we usually do, we actually convert OBJ files to C files. Let me actually, nob legacy, yeah, exactly, nob legacy. So let me get rid of this kind of stuff. So obviously I'm just in the tab mode, right, for Emacs. So how do I do that? Simp-C mode, indent tabs mode. So this is probably what I want to do. Let me restart my Emacs just in case, meine Freunde. Nice tabs, thank you so much, thank you. I worked really hard on them. So olivc, and I'm gonna go no build. .c, there we go. So now it is not complaining. So let's take a look at this entire thing. Maybe I'm gonna actually kill the build folder and just rebuild everything from scratch, just in case. There we go. So let's just wait a little bit. It's gonna rebuild everything, hopefully. And it does a lot of things, right? So it prepares the assets, right? So it also then bakes them, compiles all of the demos and stuff like that. So maybe we can run the tests. Legacy indeed. So yeah, it builds the WASM demos, it builds SDL demos, and it builds term demos. So this entire thing works natively with SDL, right? And it also can work in your terminal. This is actually kind of insane. I forgot that this entire thing does that. Okay, so in some of the previous stream, I said that I don't really understand why this project became popular. I think I just remembered why. God damn it. Okay, when I said that I don't understand why this thing is popular because it's such a simple library, I completely forgot that on top of just being simple library, it had a shit ton of cool demos that I developed for this library. I completely forgot about that. And this is actually normal for me because I developed a lot of different shit. So yeah, I apologize. I just remembered why OLIFC is popular, and I suppose it's deserved, right? Because this is kind of fucking cool. It's the same code that can work in a browser, right? So and then in here we can have demos. So Tpot 3D, SDL, for instance. There we go. So this is the native version of the same Tpot in here, right? So this thing works in the browser, and this is like a native window in here, right? And now we can even go into the terminal, all right? So, and let's actually go somewhere here, right? So like this, boom. And I can do demos Tpot 3D term. Yeah, there we go. So we can, if I zoom out, there we go. So here's this thing in the terminal, using colors and stuff like that. SDL is more laggy than WSD. I don't know. For me, SDL is actually more smooth, right? So and it's the same actual code, by the way, of demos, right? So we're just adapting, since we're rendering into the array of pixels. The library itself doesn't care where that array of pixels go, right? For different kind of versions, we just call to the same code of the demo that just renders this entire thing, and then we take the resulting array of pixels and either put it into the HTML5 canvas or into the SDL 2D texture or into the terminal, right? It's just like it doesn't matter where it goes, and because of that, it's extremely cross-platform because you can adapt this array pixel to anything. It's super easy, right? So that's pretty cool, I think. I think that's a pretty cool. So if we take a look at how all of that works, right, somewhere in the folder assets, we have Utah Tpot OBJ. So as you can see, it has vertices and stuff like that. And we have a special utility. We have a special utility which is called OBJ2C. Right, OBJ2C, and what it does, it actually converts OBJ file to C file, right? So that Utah Tpot OBJ now C file, and if you take a look at what it contains, it actually turned all of these, parameters, vertices, and faces and stuff like that into global arrays that you can include into your C code, and now that OBJ file is baked into your executable. Right, so this is basically what it does for the demos and stuff like that. So here are the vertices. It even tells you how many vertices you have, vertices count. Right, and here we have faces. Right, so and faces are just indices of the vertices. They basically encode the triangles and stuff like that. All right. So Clang has just added embed, by the way. It's not even released yet, so they just added it in a nightly or something like that. We're not using like none of this like new stuff anyway, so it doesn't really matter for us. Yeah, so this is probably the first thing that we will do. Right, so we need to take Panger and convert it to C somehow. But interestingly, I think there will be a little bit of a problems with that. So, because if I take a look at the Utah Tpot, so there's only V command and F command in here, right? I think Utah Tpot is actually too huge. We can take a look at maybe cap low poly. Yeah. So as you can see here, we only have V and F, but Panger has way more different things. It has way more different commands and stuff like that. So it has V, then at some point it has VN. I suppose it's a normals, right? So these are normals. It also has VT. I don't really know what it is. Maybe it's something, it's probably something that has to do with the texture, right? It actually does make sense because all of the values of these things are within, like they're normalized from 0 to 1, so that means they are coordinates in a texture, and the texture is probably taken from the material file, right? And I don't really know what all of these parameters mean, by the way, right? So so maybe some of them will be ignored. The way we parse all of that, I think we just fail at unknown commands. All right, so I think we just fail at them, and this one is actually rather interesting. So what the hell is that? So F, and there is different variants in here. I don't remember that kind of stuff Yeah, so faces were usually just this. So faces are a little bit scuffed in Panger, so I do not fully understand how that works. So we're gonna have a little bit of fun converting Panger to, you know, to C file, right? So we'll see how it goes. This is probably new format. Can you import it and export it as legacy OBJ? I don't know. I would like to first figure out what those things mean at least, right? Before just like frantically trying export import things. Right, so I don't think it's a really efficient way to do things. Sometimes I fall into that sort of trap without like understanding things, just frantically trying to do things, but it's better not to fall into that thing. And it's better not to fall into that trap at the beginning of the development. Let's just like sit down and try to explore things, okay? Okay, so let's go into the no build.c. And so here we're building the assets. All right, so let's go ahead and just do cmd. Right, so this is the first thing. We're going to be going to objc. So the input is going to be Panger obj, like so, Panger obj. So this is going to be Panger, like this. Cool. So, and also need to specify the output, where we're going to be outputting this entire thing. Obviously, we're going to be outputting all of that stuff into the assets. And assets, I suppose we can just say Panger C. Right. So it's obviously going to fail. Right. It is obviously going to fail, but I just want to see how exactly it is going to fail. Right. I'm really curious. All right, so let's go ahead and just do that. Maybe I can do something like assets, right? And let's go unknown kind of entry mtl lib. So it actually prints the lines. You know, there's off by 1 in how it prints the lines. So let me actually go ahead and modify that. So the entire thing is located in tools. So the tool that actually converts all of that is our own custom tool, by the way. It is our own custom tool. So here we have a line number, right? So this is the line number, and it is here. So we're starting lines in like from zeros. Probably one of the things we want to do, we actually want to start from 1. But I need to double check whether we are doing something with line numbers special. No, we're just printing them. We just need line numbers just to print them. So I think I can just do +1 and it's going to report them in correct places, hopefully. Okay, so known kind of entry mtl lib. It didn't rebuild that. So let's quickly do that. So it's going to be tools. So rebuild the tools and assets, and there we go. So I can go here and go. It doesn't know about mtl lib panger mtl. So what we can do about that? What we can actually do about that? I think for now, we can simply ignore it. All right. So I'm gonna do something like this. So if we encounter like mtl thingy. What is it called? All right, so mtl lib. We're gonna just log a warning, but we're not gonna do anything about it, right? So we're gonna just like log a warning because it's obviously gonna be very important because it contains the pointer to the image files and stuff like that. But for now, I don't think we can like do anything about it. All right, so what we're gonna do in here is just like a warning. Like unknown, like let's put it this way, mtl lib is not supported yet, right? Ignoring it, right? So we're just ignoring it. That's what we're doing. So input, can you see what I'm doing here? Okay, input file path. I think I need to put my camera a little bit lower so you can see a little bit more. So this is the line number, and I think that's about it, right? So yeah, and I'm not going to be exiting in here, as you can see here, just like return out of the function right away. So I'm going to just like let it go. Let it go. All right, so that looks fine. So, and this is what we're going to be doing. All right, so we're going to be just basically running the conversion from OBJ to C, seeing where it fails, and just either put a hack in there or implement the thing that we need to implement. So that's basically going to be the strategy, right? So, and we're going to keep doing that until we you know, arrive at a working solution somehow, right? It's probably going to be limited, right? So we're not going to jump and implement everything at once, right? But we're going to outline what needs to be implemented, right? All right, so let's rebuild the tools. So here are the tools, and let's go with the assets. Okay, so as you can see, MTL is not supported yet, ignoring it, right? So it just straight up ignoring it. Oh, all right, this one is interesting. So what the fuck is O? So OBJ format. I need to find like OBJ format specs. Can I find any specs for OBJ format? Because like I don't really know what is O. So wave front OBJ file. So we have Wikipedia article, right? So this is what we use in here. I don't see O in here, but I would like to have some sort of, okay. So named object and polygon groups are specified via the following tags. Object name, okay, so this is very interesting. So this is some sort of an object. So materials that describe the visual aspects of the polygon are stored in external MTL files. More than one external MTL file may be referenced from within object file. The MTL file may contain named object polygon groups are specified using tags. Okay, so this one is rather interesting. So is there, can we find something like G? So, okay, so there's not a single group. How many O things we have? Okay, so this is a single O, right, and we're basically within a single O object file. Very interesting. That is actually very interesting. So I guess for now, we're going to be ignoring all of that, right? So it's okay to hard code all of these solutions, right? It's okay to hard code all of these solutions. Q kind SV O. Right. So, and we can do something like fprintf, std error, and we can basically say zu info processing object, you know, this thing. I want to print the name of that object, right? Because in here we have like an object name, as you can see. So this is an object name. I want to actually print this entire thing. Right, so this is input file path, line number, and then we need to specify the name, and the question is, how do we even parse that name? So there are different ways to parse that. So as you can see here, yeah, so this is probably what we can do, because kind is sort of chipped off of the line, right? So we parse the line, we chipped off the, you know, by a space. So now kind is a command, right? So some of the command or object or whatever, and line contains the rest of the arguments. So the most logical thing you want to do in here is basically trim the line, and the line basically contains the name already, right? So we can even do something like string view name line, right? So that's basically the name we have in here. And I can put it in here. There we go. So let's actually take a look at how it works. So, and by the way, in here, I probably want to say this is an error, right? We have different levels of logging already. Look at that. We're developing our own custom logging system, right? So we have errors, info, warnings, and stuff like that. Right. So you don't need a login library or login framework. You just need a way to print on a standard output. Come on. Right. Don't overcomplicate shit, bro. Don't overcomplicate shit. So, Only for J, yeah, exactly. So assets, and okay, so here's the warning. And then we have banger, your mom's banger. So I forgot to put a new line in here. So by the way, I see the subs. I'm gonna acknowledge them a little bit later. Just a second. Don't worry about it, guys. Don't worry about it. Thank you for all of the subs. All right, so it's gonna be assets. There we go. All right, so MTL is not supported yet. Importing it, processing object banger. There we go. So you know what I want to do? I want to put some sort of like stopgap in here, so to speak. So essentially, if you encounter several objects as you go, we should fail. Right, because as of right now, this object-to-C thing supports only one object, like it can convert only one object. So if there are several objects within a single file, I think it makes sense to maybe just stop. Maybe not, actually, that's very interesting. But I mean, for now, we can just fail, right? So it will be interesting in the future to support more things, but I prefer to just implement only the things that that needed to make the demo work. So what we just need to do, we just need to extract some information out of the object file and put it into the C file, so we can just display it in a nice way, right? So the full support of OBJ format is not really a goal of this entire thing, and it's not really, we don't even have enough resources to do that, right? So maybe we could use some sort of a library, but adding a library adds a lot of moving parts and stuff like that. So I think I even already talked about it in a previous Olivet stream, so I think I'm not going to go into that again. All right, so let me take a look at the subs. Thank you everyone who subscribed. Oh my god, that's so many subs. Fedrutini, Desimonde 85, Asan Fool, Mediode, thank you so much for Twitch Prime with the message hello. Nicholas Danilon, thank you so much for T1 with the message 11 months supporting the recreation programming session for 11 months more. Thank you for supporting the recreation programming session. So there's some sort of emoji thing, people spamming Panger, that's nice. Okmatia, thank you so much for tier 1. Ruse Junior 08, thank you so much for the trying with the message. Thank you, Mr. Zizin, for the awesome content, Zodin Pog. You're welcome. And Atlas 87, thank you so much for Twitch Prime. Thank you. All right, very cool. Very cool gear. So, we may want to have some sort of a boolean in here. One object encountered. So this is going to be false. And when we encounter this thing, one object encountered true. All right, so and in here, if one object encountered, we actually want to throw an error, right? We want to throw an error. So we can say something like this. So let me think. OBJ to C, but it would be better maybe to actually say a specific program. Do we have a program? Yeah, so if I rename this program, I want to be going there and just renaming it, so I can actually put something like this in here. So input file path, line number, and program name. Right, so program name, supports only one object as of right now. So it would be also nice to say where the previous object was encountered. Right, so one object encountered. So to do that, by the way, we need to keep track of, well, I mean, we already know file path, right? So because we're handling that single path. So we need to keep track of the line, right? So one object line. One object line, which is originally 0, right? And that means that here we just do one object line number, right? For the consistency, let's actually call it number, right? So the reason I want to keep track of that is because I just want to report that. That's what I want to do, to explain to the user that where is the mistake. Right, we already see the error. SZU note, we already processing this object, right? And since we're processing only one file, right, so we can process only one file, we're going to specify the same input file path, but we're going to be using one object, right, line number, something like this. And after that, we're going to just do return defer, and I suppose error is indicated with 1. Right, I don't really know where we're returning. So yeah, we're returning out of the main, right? So we're returning out of the main. So this is basically what I'm doing here. Because like the way we treat all of that, it only makes sense if you have a single object. If you start having several objects, it stops kind of making sense, right? So because of that, we want to have some sort of like a, you know, warning that tells you that something is wrong. So you probably want to go ahead and implement more features for this utility, right? So thank you so much for more subs. While AI, thank you so much for tier 1. Hypnotic 2, thank you so much for Twitch Prime. And Mr. Yudzik, thank you so much for tier 1 with the message. People happy indeed. I do agree with that. I kind of want to test this thing. Right, so I'm in a wrong place, by the way. In a wrong place. AI learned how to subscribe to Twitch. Yeah. So you just put AI into your name and you suddenly become an AI. That's how it works. Right, that's how it works. Okay, so yeah, processing object banger, right? And in here, maybe somewhere like down there, right? I'm gonna do your mom's banger, right? So this is how we're gonna do that. And if I try to now compile this entire thing, right? So we're already processing this object. So supports this thing, supports only one object as of right now. We're already processing this object. Okay. So as you can see, right, so it just tells you that, well, you're not supposed to do that. And the object is already this one. So maybe in the future, we're going to actually support more objects. Why not? I don't see any problems with that. But as of right now, I just don't want to be dealing with that. Right, I just don't want to be dealing with that. Okay, that's cool. So what is a VN? VN. This is very interesting. I suppose this is normals, right? So list of vertex normals in XYZ form. Normals might not be unit vectors. Aha, that is understandable. So that means we should have the same amount of normals as the vertices. Right, so let's do the interesting thing. Let's literally count how many vertex normals we have and compare it to the amount of vertices. We already have, vertices in here, so vertex count and stuff like that. Oh, so we print kind of quite a few stats in here. This is actually kind of cool. So I think we can even see those stats in here. Yeah, when I'm converting like cap low poly, right? So here's the input, here's the output, here's how many vertices we have, right? So this is like a range of the vertices from the minimum to the maximum and stuff like that. So this is how many faces we have, their indices. Yeah, so we can do the same thing with the normals, right? So we can just, as of right now, count them and compare that they have the same amount as vertices. 3,644 vertices, look at that. Look at that shit. So how quickly does it even process that? Look at that. Look how quickly it processes 3,644 vertices and 6,320 faces. Like, it takes us like less than 100 milliseconds. Like, look how freaking fast your computer is if you just don't use bullshit languages with like huge overbloated runtimes. It's freaking insane, honestly. It's fucking insane. And it's not even like I'm advertising C or anything. I'm just like saying, just by using language without bullshit. Not even like doing anything special, not doing any optimization, right? So I'm not a very much like a performance person, right? So I don't know how to do high performance optimization or anything. Just like don't do bullshit. And you get so much fucking performance. It's freaking insane. Anybody can be a high performance developer in 2024, honestly. Like literally anybody, even web guys. They just need to switch from bullshit language to a real programming language. That's it. They don't even have to change like how they program. Just like write in a language that doesn't have bullshit runtime. That's it. You're gonna get faster. So it's freaking insane. Hot takes. Anyways, I remember there was some sort of like a meme running around on Twitter. Some freaking web dev just accidentally tried Go and got fucking blown away how quickly it reads files or something. They just couldn't fucking believe, right? So I don't remember who that was, but it's just like, it was so fucking funny. It's just like, web dev discovered native language. Like, holy shit. That's exactly what I'm talking about. It's just like, don't fucking use bullshit languages, and you just like, you get so much performance. It's sometimes even worth it. Like, quite often it's even worth it. Just don't do bullshit. Right. So you can simply, in 2024, there's so much fucking bullshit. You can make better software, but just by just not doing certain things. Not just by doing more, but simply by not doing things. Right. So imagine a world without developers. It's not even about the skills. Guys, we're at the point where it's not even about the skills. Just don't do bullshit. It doesn't require any skills. Just like use a normal fucking language. That's it. Just don't use language that add too much fucking bullshit to the runtime. It's more about being aware, right? So it's really not about the skill. You can keep the skill the same. It's just like being aware of what the fuck is going on your computer, and that's it. So something interesting from this used. There was a discussion on GitHub where a web dev was arguing that CPUs are in megahertz and not gigahertz. He was in disbelief that CPUs can perform billions of operations per second. Yeah, it's like, and it's not a really skill issue. I feel like people just don't know. People just don't fucking know what their computers are capable of. It's just like somebody has to tell them. But obviously, those people are not listening to guys like me for some freaking reason. Maybe just look too crazy, right? So, but somebody has to tell them, right? So I don't know. You have to spread the message. Like I keep talking about that. Those motherfuckers don't believe me, right? There's maybe something wrong with the way I talk. Maybe because of my accent, right? So because of my Russian accent, they think that I'm, trying to deceive them, spreading disinformation. Because of my accent, everything I say sounds like a disinformation. So maybe I should make a small break. Yeah, nah, let's actually first count the normals and compare them and stuff like that. So let me see. Deceiving into writing better software. Exactly. Right. So let me try. So here we have vertices, faces. Let's introduce like a normals counts. It's gonna be 0. And we don't really support that. Okay. So we're gonna do that. And else if sv eq kind sv vn, it was vn, right? So a normals count plus 1. So and in here we're gonna just printf normals and zu. We're gonna just ignore them, right? For now, we're gonna parse them a little bit later, but we're gonna ignore them for now. Imagine GitHub was written in non-bullshit language and actually worked for once. Well, I mean, it works fine 90% of the time, but yeah. Anyways, let's try to just freaking build the tools. Well, I'm in the wrong place. There we go. All right, assets. There we go. So we have VT. So what the fuck is VT? This is interesting. So texture coordinates. Right? I already guessed that correctly. But how many of them? So texture coordinates. These will vary from. Okay, so I presume this is the texture coordinates per vertex, right? So this is per vertex, and that means we're gonna have the same amount of them as the vertices. So it kind of even hints us that this is the same amount as the vertices because they all start with V. This is actually a pretty cool format. I really like that. Right, kind of cool format. Right, so let me go ahead and just add all of that texture coordinates. So size t texture chords count. All right, so vn. So else if sv kind sv vt texture chords count +1. And in here we're gonna do just simply texture coordinates, but that creates a huge alignment issue. Texture chords count, so now I have to realign the texts. So AI people are constantly struggling with aligning AI. I struggle with aligning text. We're not the same, okay? We're not the same. Anyways, so this is the tools. Let's go. Let's fucking go. Assets. All right. A known kind of entry as. Damn. Didn't expect that shit to happen. So by the way, where do we start F? Yeah, so this is where it starts. What the fuck is as? Use MTL Panger mat. So this is where we start using the material and stuff like that. All right. So let's try to find what is as. Smooth shading. I just clicked. Okay, smooth shading across polygons is enabled by smoothing groups. Ooh, smooth shaders can be disabled as well. Okay, so this is sort of like it's a basically hierarchical structure, right? So you can have object, you can have groups within object, and you have smooth shading groups and stuff like that. So this defines a group. So I guess I'm gonna be ignoring that. And what is, so one basically means that it's enabled and then you can disable all of that stuff. All right, so that's cool. So what that means, I'm gonna be ignoring all of that, right? So I'm kind of like, kind of reverse engineering the format, right? So by trying to parse it, it's kind of similar to how you basically reverse engineer binary formats as well. You're just trying things until you encounter something unfamiliar. Then you look at something unfamiliar, you analyze it, maybe implement it, maybe put a stopgap, run it again, encounter something unfamiliar, and so on and so forth. So it's basically like a reverse engineering thing. Right. So which is kind of fun. Honestly, I really like doing these kind of things. I think they're super fun. Right. People who are not enthusiastic about computers and programming don't like do these kind of things because it's boring. It's for you. So how do I make money out of that? How do I make money when? How does it help me to land a job at Google? What the fuck is all of that nerd shit? That's an average tech viewer these days, by the way. Not you guys in the chat. Since you're here, you actually appreciate recreational programming. You're actually enthusiastic about computers. I believe in you. But outside of this small bubble, there is like shit ton of these normies who absolutely fucking hate what we're doing right now. But they somehow trying to deceive you into thinking that they are really enthusiastic about all that. But deep down, in their soul, they don't give a shit. Right, they just want to land a job somewhere at Google and color buttons all day. That's what they want. Right, so anyways, it is what it is and it isn't what it isn't. It's kind of sad. Anyways, thank you so much, and Quadrant for Twitch Prime. Thank you. Okay, that's a very IDFSK. Thank you so much for Twitch Prime with the message. Let's fucking go. Let's fucking go. Landing a job at Google just to leave it after a few months and start YouTube channel. So this is why I left my job at fucking Google. Yeah. I can imagine people literally doing that, right? So because why not? Because obviously you won't be able to stay very long at Google. So, but with the ex-Googler status, you can make a lot of money on YouTube, right? So that's how it works. That's the current trend. So we need some sort of like a way to separate this noise from the signal somehow. Unfortunately, all of the filters kind of working against us, right? So all of the, filters in social media and algorithms, they still clamping together all of that bullshit content with genuine programming content. So it's very, like, we're drowning in all of that bullshit. So we have to somehow develop mechanisms of, separating all of that. So the submod, for instance, right? So that we put in here is one of them. It's not, but it's not sufficient, honestly. Not sufficient. So, anyways, so what I want to do in here is just want to put a warning. So smooth groups are not supported right now. Ignoring them. Can you see that? Ignoring them. Boom, boom, boom. So input file path, and this is the line number, but we're not going to do anything, right? So we're just going to put a warning in here and just move on. Just simply move on. I think the most interesting part is going to go with F, right? With the faces. I don't really know how we're going to be even approaching that, because faces are kind of weird, honestly. They are triples of these things. It's just like, what the hell is that? I presume that maybe the first things are the indices within vertices, and then these are indices within something else, probably within the material. Right, probably within the material, which is this Panger mat. It's a Panger mat material. This ID does not exist anywhere within the file, right? So maybe it does exist within the Panger MTL. Yeah, there we go. So here is the new material, Panger mat. And that material, these are the parameters of the material, I presume. Right, we're not going to be supporting materials or anything like that, right? So we're not going to be doing, at least today. Maybe we're going to be doing that later, but at least today we're not going to be supporting that yet. Okay, let's try to rebuild the tools. So I'm going to go in here. So tools, and assets. Let's go. Unknown. Okay, so use MTL, another unknown parameter. We're probably going to be ignoring that as well. So by explicitly ignoring all of that, we also kind of outline the things that we need to implement. All right, we also outline all of that. So here's the MTL. So I'm going to put something like this in here. If, maybe I'm going to put space in here. I usually put space between if and open parent. So can sv use MTL material. So use MTL is not supporting yet. It's not supported yet. Ignoring it. All right. So and then I'm gonna rebuild the tools. Let's go. Assets. Cool. Nice. This is very cool. This is actually very cool. Faces got just parsed just fine. So the amount of normals is actually less than the amount of vertices, which makes me think, what the fuck is going on? Like, what the fuck is going on with that? And also the amount of texture coordinates is different than the amount of vertices. I have a hypothesis that those things, these triples, vertex, normal, texture coordinate. Vertex, normal, texture coordinate. That's probably what they are. I think this is my hypothesis, because it kind of does make sense, right? It kind of does make sense. And the fact, yeah, vertex, texture, normal. But I mean, the fact that it's a triple of these things, right? So I guessed that correctly. And also the fact that it just, worked is kind of sus. That probably means that I already kind of handle all of that within the faces. So let's actually find the code where I do all this. Do I do anything special about that? All right, so I convert, I basically divide this entire thing. Ooh, this one is interesting. Yeah, I don't fucking do anything about that. So essentially, I just look at the prefix. We can even grab the prefix somewhere here. We can even grab this prefix somewhere here. So that's the prefix. I just convert str to L, and I encounter the first thing that is not that. Right, so I just do this. All right, so then I just stream all of that, and then I convert to that. So I kind of get stuck at this thing in here, So I parse faces absolutely incorrectly. It would be kind of interesting to actually see what is going on with these faces. I think it would be really, really interesting. But what's funny is that this is basically the last thing, right? So it basically already does everything we needed to do. It's just like we probably need to fix the face parsing, right? And it will be fine. So let me take a look at how we build OBJ to C. Do we add any debug information? We do in fact add some debug information, which is cool. Let me go into the compilation mode. How do we call this thing? So this is how we call it, right? And I can call it separately like that. Very cool. So here are the parameters. I want to open this entire thing in GF2. So maybe it makes sense for me to open it like that. So I'll open it in GF2. I want to open it as asynchronous, right? So it doesn't block Emacs. I want to break at the place where we handle the faces. Well, I mean, yeah. So it's essentially break OBJ to C at 281. Okay, so do we have any breakpoints? There we go. So this is the breakpoint where we're going to be breaking and shit. And now I want to just do the conversion. I just want to see how this entire thing is going to be parsing. There we go. So we stopped at here. Let's take a look at the line. So we can take a look at the locals, right? So this is the local variables. That's a lot of shit we have at the local stuff. So I didn't see the line. Okay, fuck that. So what is line? Okay, currently we're looking at 23,123, right? So we're looking at exactly at that parameter. And if I take a look at the Panger OBJ, where is the Panger OBJ? So where is the first ever app? 23,123. So we're looking at here, exactly in the debugger. Right, in the debugger. What is a vertex? It's a mathematical point. Yes, it is. Okay, so in the 3D formats, they usually do what? They have vertices, which are points in 3D space, and it's just an array of points in 3D space. And then they have faces, which are basically triangles, which are triples of indices, within the vertex array. You get the point. So that's how it usually works, right? They have arrays, and then they have basically the objects that refer to certain vertices or normals or something like that through the indices. So this is basically the kind of format we're talking about. Right, so this is how they do that in 3D graphics, if I understand correctly. Like, I'm not a 3D graphics guy, but I have like a surface level of understanding of this entire stuff. Okay, so we have A, B, and C, and these are the indices of the vertices. So we might as well just put A, B, and C. Right, and if I understand correctly, A should be 23, B should be 3, C should be 11, but it's not as it like that right now. Right, so if I do, A became 23, right, so then we update the line. As you can see, it points at hash, and we just like update some stuff in here. So then we do trim, and it didn't work because trim only works with spaces, right? It only works with spaces, so this entire thing didn't really work. So then we convert B, and we end up with 0, right? And then we just update this entire thing. So we basically stopped at that single hash, and we end up with only parsing the first index and ignoring the rest of them, because we just don't know how to handle all these slashes. That's basically what's going on in here. We can even literally see that. So that's why faces are absolutely broken right now, and it's pointless to even look at that. We can even take a look at what exactly it generated. Actually, it's kind of cool, probably. So Panger.c. Okay, so here's the vertices. Vertices look more or less correct. And faces, they even end up -1s. Not even zeros, by the way. Not even zeros, but -1s for some freaking reason. Oh, I know why. I know why. Because this is actually kind of funny. Because in object files, the indices are 1 based. Don't look at me like that. I didn't invent this for, okay? I didn't invent it. They're one based. But I want to have the format, when I converted everything to C, I want to just be able to do things like, let me show you, right? So basically, just a second. So I have faces, I have an ith face, I take 0, and then I say, okay, I want to take a look at the vertex that, and then vertex that, and vertex that. So I have two options, either subtract 1 from the indices, or maybe add additional like 0 vertex in here. So I decided to just subtract 1, so that's why it ended up like that. And it's kind of cool, right? So in the sense that it just tells you that it's an invalid vertex, some sort. Ew, yeah, exactly. Like, I don't know. I didn't invent that. Just like I have to work with it, right? So it's a legacy. It's a legacy I'm dealing with. So it is what it is, and it isn't what it isn't, my friend. Is it not? I think it is. So let's actually confirm what the fuck are like between the slashes, right? So the first one is the index for the vertices, and what's the next one? So let's take a look at the faces. All around me are familiar faces. Sorry. So, vertex normal indices, vertex texture indices. Ooh. Legacy. Ooh. So is it too much flash banging right now, guys? Is it too much flash banging? I can do something like Chrome flanks and maybe dark mode. Enable. Relaunch. Because I think it's too much flash banging. Oh, we have a spec in here. How huge of a spec this is, by the way? Maybe I should look at it at some point. But I mean, so far Wikipedia is okay. Look at that. Look at this Wikipedia. It doesn't even show the proper icon. So valid vertex index matches the corresponding vertex elements of a previously defined vertex index. If the index is positive, then it refers to the offset. Okay. So vertex texture coordinate, optionally texture coordinates indices can be used to specify texture coordinates, blah, 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 blah. Vertex normal indices, okay, so that's totally fine. Optional normals, okay. Yeah, okay. This is actually kind of easy to implement, I think. So after parsing the index, all right, and doing this thing, it is actually super easy. It is actually super easy to then look at line data like 0, but you also need to make sure that you didn't hit the end or anything, and just if it's equal to slash, okay, so that means we're parsing you know, the now the virtual, like the texture coordinates, right? So, and after we parse them, we can look at it again if it still contains the slash. So okay, it's another thing that we need to parse. We need to parse normals. So yeah. So this is usually something like this, and I think I'm gonna just put it to do in here, like parse format like this. So for now, since we're not handling all of that stuff, we can just ignore them. Yeah, we can just literally ignore these things, texture, normals. The way we already ignore the things like that start with VT and VN because we're not using them. Right. So the goal of today is going to be at least displaying the shape, not really coloring it, texturing it, or anything like that, at least displaying a shape. Then I plan to texture the shape, right? So it will be interesting to texture the shape. And since we have normals, we can probably add some lighting to it, right? So we can light it properly, right? So because we know like how the light should be computed and stuff like that. So yeah, that's what we need to do in here. Sounds like a plan? Sounds like a plan? Okay, so let's make a small break, and after the break, we're gonna just do that. Okay, so let's go ahead and just continue, right? How we're gonna be approaching this entire stuff. So as of right now, we're gonna be ignoring the texture and the rest of the thing. So where is my to-do? I remember. Oh, okay. So it's in the wrong place. I see. So here I'm just computing low and high, right? So I'm computing the range of the indices, right? So I think I'm going to put it in here. And so if I encounter, right? So if I encounter line data at 0 equal to slash, I suppose one of the things I want to do, I want to get rid of that slash. So to get rid of that slash, I need to do +1 and also count -1, because line is a string view, right? So line is a string view, as you can see, and string view, if I'm not mistaken, so we're using SV in here. So do we have SV? So it's a dev dependencies, probably sv.h. String view, it's a pair, it's a count and a pointer. So I suppose, remember there was a special function to chop a single character from the left. Let me see. Chop, yeah, okay, so there's a chop, yeah, there we go. So I can just do it like that. And if you take a look at the chop left, what it literally does just +n minus n, literally the thing I do in here. It also has a bunch of checks in here, right, it also has a bunch of checks. But that's about it. Alright, so I think it's better to use this one, like so. So it's gonna be a line, line, just simply 1. And what's funny is that, what if we reach the end of the line? I think we have to be a little bit careful in here. So line count greater than 0. Right, greater than 0, it has this slash, we remove that single slash, right? And I suppose what we okay, let me put it this way. I think it would be probably better to just chop characters while the current thing is not space, right? So that would be better, like while line count is equal to 0 and this thing is space not, right, is space not, we're gonna be just chopping it off, just like chopping it off until we encounter the space. We encounter the space, we trim this stuff, right, so we parse the first number and so on and so forth. I think that's a good idea in here generally, right? And we can actually do that like everywhere in here. So we updated the line data, right? Simply updated the line data. Funnily enough, this is a kind of a broken thing we do in here, because we updated the line data, but we didn't update the like, why did I implement it like that? Can anybody tell me why the fuck did I implement it like that? That's kind of stupid, honestly. Why didn't I update the count as well? So yeah, so on top of just doing that, what I have to do is like count, but I have to do it like this, right? So end pointer minus the data. So this is how we moved forward, right? So if you take a look at the implementation of strtol, it's rather interesting, right? It accepts what you need to parse, but it also accepts the pointer to the endpoint. So essentially, if you have a string that just contains some numbers and some other bullshit, and you have a pointer to the beginning of the string, and you pass this pointer to the strtol, what it's going to do, it's going to just go and parse the digits until it encounters something that is unknown, right? And through the end PTR, it is going to return you pointer to that first character that is not a number anymore. And this is how we know how much we need to chop off from the string. So for some reason, what I was doing, I was just updating the data of the line, but I wasn't updating the count of the line, and that's kind of stupid. That is a sign of a dummy dum-dum. Absolute sign of a dummy dum-dum. But what's funny is that I can kind of figure out how much I need to chop off, right? So since this thing kind of, I know where I start and I know where I end. I can subtract this thing from this thing and get how much stuff I actually accumulated this. Right. So I can just take end ptr minus line data, and then I can say, okay, sv chop left that from here. That would have been more correct in here. That would have been more correct in here, I think. So yeah, so in here we parse the index, we updated the lows and highs, right? So then we chopped how much we parsed from this entire thing, and then we basically trimmed off everything that is not space, right? If the line count is greater than 0, and the first thing in here is actually that, might as well just do it like that. We just keep chopping off one single character. That's what we're doing. And we kind of want to do this entire thing for each index in here, right? For each index in here. So in here, we parse the index, then we just want to repeat that. So when we have only 3 indices in here, so it's going to be that, and just repeat that. And that should be it, right? So that should be it. So let's go ahead and try to build the tools. Let's try to build the tools. Do they build? This seems to be building. So what I want to do, I want to do this thing. So this is GF. So let's actually kill it. And I want to do a run. Does it still? Okay, so I still have in the clipboard this run thingy, which is cool. I want to do a breakpoint. I want to break at obj to C, and where we're gonna be doing all of that. So 281 break. Let's take a look at where we exactly braked. Okay, that seems to be correct. Let's do the run. All right. So no input was provided. Oof. Really? Are you for real, my friend? I suppose what I have to do in here. Yeah. One more time. Okay, so we are in here. If we take a look at the line, so what the line is pointing at? The line is pointing at 23, 1, 23. Cool. So I'm interested in A, B, and C. Right. So let's go through the entirety of the thing and see how it parses things. Okay, so we parsed successfully 23, as you can see. So 23. So the next thing, we updated this kind of stuff. So we are about to chop off this 23 from this line. Okay, so we got this thing. Now we have a loop that is going to be iterating and chopping off one character by one until we encounter space. Oh, that actually jumped. It probably got optimized away. Do we have any optimizations in... so when I do obj to C, I don't really enable any optimizations, but it just jumped over the entire loop as one single thing, which is, I don't know, maybe just optimized it somehow, but whatever. But that was fine, but it cut out whatever we wanted to cut out. Okay, so B is now 3, right? Everything is updated. We update the 3. We cut out the rest of the stuff. Okay, so then we do 11. And everything's fine. So is it even correct from the point of view of like Panger OBJ in here? Right, so 23, 3, 11. Okay, so I think we parse this entire stuff correctly now. Right, so we parse this entire stuff correctly. We remove that, and then we just append the faces. Okay, so that's cool. So I think we fixed this entire thing. I think we literally fixed this entire thing, so that's pretty cool. All right, so I can do the tools, and then I can do the assets. All right, look at that. So this is how many faces we've got. 1,000 of faces for the Panger, right? So some of the faces, a bunch of warnings in here as well. Info, warning, because we have some things that are not supported in here, so we just simply ignore them. All right, so I would like to take a look at the generated Panger-Wenger. So assets panger.c. All right, so here are the vertices. They make sense. They kind of like from -1 to 1 or something. So here are the faces. All right, so they look fine. They also look fine. Very cool. As you can see, there was 23,311, but they turned into 22,210 because one based and 0 based. Okay, so that's pretty cool. Can we turn that into demo already? So how do we even build the demos? So teapot, so build asset. So this is the teapot. Here is the demo. Teapot 3D. Now, what if I do Panger 3D? So that's what we have in here. So this is a Panger 3D. How do we iterate the names? So in the names, we just iterate the names and we just build VC demo, right? So we just build a single VC demo. And how we build wasm demo. So we just provide the name of the demo, and the name of the demo corresponds to name of the demo.c in here. Okay, so we need to go to the demos and find cap 3D. So the fun thing in here is that the demos that are based on 3D models like this, they are the same code. Right, so if you take a look at this, so we have two demos in here, cup and Utah teapot. So here's the cup and there is a teapot in here. Literally the same, right, we just include different assets. We just include different assets. So, and essentially to create a Panger 3D C, what I have to do, I have to include assets Panger C, right, I suppose Panger C, and I just include the model 3D sort of template, right. So, and now I should be able to build the demos, right, so does it build the demos? Do we have a Panger anywhere? I don't see the Panger. It doesn't build shit, unfortunately. Oh, okay, it builds them in triples, I see. So at some point it's gonna be building Panger. So it's building teapot, so it's soon gonna build the Panger. Oh, look at that, it's building Panger. It's building actually 3 versions like WASM, Term, and SDL. So interestingly, we can already test the native version, right? So we can test the native version. So we can go into the demo, Panger SDL. That was easy, actually. So there we go. We can probably maybe scale it somehow. Yeah, that's pretty cool. So this is the Panger. It doesn't support the textures and stuff like that, so chat is cool. Yeah. So that's basically 3D model of this emote, right? So yeah, we have Panger in 3D. Panger, the your mom Panger. So we don't have textures, lighting, and everything like that, but we can add support for them a little bit later. So what I want to do, I want to maybe scale it up a little bit. So let me see. Do I have no build? Here it is. So when I'm building the assets, build the assets, you can actually scale things, right? As you can see, there is a parameter to scale. If I just run build tools obj to C, yeah, scale the model. And I suppose this is just a multiplier. So that means I can just scale it in like twice. So I'm gonna just do no build assets. Let's fuck. Let's do assets. So we rebuild the assets, and now I probably want to rebuild the demos, but I can rebuild specific demos. I think I can rebuild Panger 3D. Yeah, there we go. So it allows me to rebuild a specific demo, and I can now try to run that specific demo. Now it's actually lagging a little bit. So I think twice as big is too much. That's for sure. I think twice as big is too much. So let's try to maybe tune it down a little bit, maybe like, you know, half, right? So let's just scale it in half. So we rebuilding the assets, and then we're rebuilding the demo. I think I can run the demo after I actually do that. So yeah, so I probably have to, yeah, I have to specify the platform. I'm rebuilding it for SDL, and then I can say, okay, also run it as well. Yeah, there we go. So the build system is actually super powerful, honestly. It's actually rather powerful. So we can do shit like that. So now let me do it like this. I'm rebuilding everything. We can even test it in the terminal, by the way. We can test it in the terminal. So demo, no build, demo Spanger 3D, term run. All right. So that's actually, it's pretty small, but I mean, it's readable. You can clearly see that it's a Panger in the terminal. Right, you can clearly see all of that. Damn, I actually developed such a powerful infrastructure for... this library is cool. I completely forgot why it was so cool. Right, so because there's this very powerful infrastructure of things, right? I can add new things and stuff like that. This is so fucking cool. It's not okay. So it's basically censored. It's not safe for work, Panger. You might not like this, but this is big Panger performance, exactly. So let's actually run it in the browser. Let's see how it's gonna look like in the browser. So I probably need to update index.html. And I'm pretty sure in the index.html it's also pretty straightforward, right? So here's the teapot. I'm pretty sure it's just, you know, putting it like that. And so I probably want to get rid of this stuff and simply query replace query replace teapot with Panger. Query replace teapot, Panger, boom, boom, boom. Well, I mean, yeah. Panger. Yeah, I have no idea. Okay, so I'm gonna remove that. And then when I'm running the demos, all right, so I'm gonna be just running it like that. So we have an entire framework for running these things. Okay, so I can try to run it locally. So Python 3 m http server 69 or 69. So localhost, let's take a look. All right, so this is what we have at localhost. Maybe I'm gonna actually scale it down to 100. And here's the Panger running in your browser. So that's pretty cool. So here's the Panger. Your mom's banger. It's pretty cool. It's pretty cool. It's pretty cool. We need to add a description. Okay, so the Panger, the mascot of Sodding Discord community. Right, so I probably need to give the link to NeoCities, right? So because this is the official website of Panger, it's honestly it's getting fucking crazy. Every time I open it, it's getting crazier and crazier, and it's a little bit fucked up by the dark mode. So I think I'm gonna do just Chrome flags, and I'm gonna disable dark mode. Right, so super quick and relaunch the browser. Browser. It's a browser. All right, so this is how it's supposed to look like, and it's just getting... I don't remember it actually throwing that many bagels, honestly, but yeah. So there's a lot of shit in here. Okay, so how are we gonna be doing all of that? So Panger, I don't know, like I want to give the link to that. Okay, let's put it like this. So it's gonna be href and a. So the character design by so Siphonalter, do you want me to credit? I think I should credit you. I'm pretty sure I should credit you. What is your GitHub account? So yes, okay. Phone Altera, but I don't know how to lane layer. Okay, so lane layer. So that's the famous author of the Panger. All right, so all right, cool. So that's you, Pog you, href. So the character designed by the model by so let's take a look at the author. So assets, so there's credits in here. Oh yeah, so I probably need to do Panger OBJ author There we go. Index HTML. Href. Look, I'm a web developer. I'm doing web. So Panger, the mascot of Coding Discord community, the character designed by... okay. So now, if I go to here, I need to refresh this entire thing. So Panger, the mascot of Coding Discord community, the character designed by line there. It's kind of weird that it actually, you know, puts it on the next line, but I don't really know how to make it keep it on the line, next line. So what else did I want to do? Because there's also source, right? So we also say the source and BSP and BSP. So this is that. And I'm pretty sure the source is going to be very easy to port. Just replace. Oh. That's really funny. Nobody actually told me that. So it's a teapot 3D. Teapot. We could replace teapot. Panger. Boom, boom. All right. So Panger app 3D. Panger, the mascot of Coding Discord community, the character design that, and yeah. Weirdly, okay, so everything's fine. All right, so what I need to do, I need to do a committee, right? So we are committing WASM as well. And here as well. So Panger, also it has a zip, but I don't think I'm going to be including zip, right? So we only have OBJ, MTL, PNG. I'm committing all of that just in case, because we're going to add support for the rest of the things a little bit later. Right, so add Panger 3D demo, right? And I'm going to push that right into the repo. Okay, so we did it. We actually freaking did it. We added like preliminary, is that how we say that? Right, so it's just like you know, initial Panger support, right? So it's a very rough one, just super quick one, super hackish one, right? Because the model actually supports way more different things that we just simply do not support. One of the things I would like to add next is some sort of texturing, right? So we have a texture, we know how to map certain faces to certain textures. We know how to even do the textures because we do it in here, right? We literally know that. So we just need to add that capability to our infrastructure, to our system. And I think we can do that on one of the next streams, right? So we'll see how it goes. I think it's going to be interesting. It feels pretty good to get back to Olivet's development. It's kind of a cool project, honestly. I don't know why I was hating it some time ago, because I thought it's very simplistic. There's nothing particularly interesting, but I suppose the interesting part of the project is not in the library itself. It's in the infrastructure. It's the friends we made along the way. That's what it is. That's what it is. It's the friends we made along the way. So it's actually kind of cool. And yeah, so it definitely needs some sort of textures, right? Because it's kind of like a third boring 3D thing. It's like literally the same demo the third time. Nothing particularly special. Right, but as soon as we add textures, it's going to be fucking awesome. It's going to be fucking awesome, mate. All right, thank you so much for all of the subs, resubs, recommitments. So let me take a look at everyone who recommitted. I guess nobody recommitted, okay. That's fine, that's fine. I don't get any money from the subs anyway. All right. I guess that's it for today. I hope it was fun. It was a chill stream, nothing particularly special, right? We didn't do any slop for engagement. We didn't do any slop for the views. We just did like a chill stream for the OGs. These kind of streams are really important sometimes. Really important. Okay, that's it for today. Thanks, everyone. Love you.